Cars are vital instruments to everyday life. We use them to get to work, go to school, and fulfill our everyday needs. Today, I will be discussing the physics of cars. So, in regards to constant velocity, zero total force results in zero total acceleration. If nothing reacts with the car, then the car surprisingly won't do anything. Since acceleration is the change in velocity, we will calculate acceleration equals change in velocity over time. To support this, we're going to use an example. So, let's say a car is going at 80 meters per second and stops to 0 meters per second within a span of 10 seconds. To calculate acceleration, we take the change in velocity, which is 80, and divide it by 10 seconds. As a result, we will have a total acceleration to be 8 meters per second squared. Horsepower is another concept that can affect cars. So, a thing to know before we talk about horsepower is that horsepower is measured in watts. 1 horsepower is equal to 746 watts. Horsepower measures how much force the engine can apply to the car in a given amount of time. We take the equation for instantaneous power, P equals mv, and the equation for force, F equals ma. To get watts, we combine the equation to be P equals mav. We divide the answer by 746 to get horsepower. This is how engines have their own specific horsepowers in various cars. Our last topic today is the center of mass. In cars, the engine is usually used as a center of mass. This is important because all forces act on it. For cars, the ideal placement for the center of mass is the middle section of the car. If the center of mass were in any other place, the car turning in on a sharp corner could probably end in drastically results. In conclusion, there are many forces that act on cars. Manufacturers take their time to figure out the optimal specifications so that the car can perform at its true potential. Cars are very important in everyday life, so have fun driving.